Complete Guide to the Best AI Models of 2025. GPT 4.1/GPT 4.5 OpenAI, the king of text and code generation. The most powerful language AI in the world. Can write books, articles, letters, scripts, legal documents at an expert level. GPT 4.1, available via API, is the best AI for coding, from websites and games to complex algorithms. Supports up to 128,000 tokens. That's entire books. Fun fact, GPT-4 scores in the top 1% on exams like SAT, GRE, LSAT. Midjourney V6, master of visual style and imagination. Creates breathtaking illustrations in anime, fantasy, retro-futuristic, and surreal styles. Especially good at conveying emotion, lighting, fabrics, and mood. A favorite among designers, writers, manga artists. Fun fact, Midjourney is used by Netflix and HBO directors for storyboarding. AlphaFold DeepMind, breakthrough in biology. The first AI to predict the 3D structure of all human proteins. Saved decades of lab research in molecular biology. Used in drug development, cancer research, and DNA studies. Fun fact, AlphaFold was named one of the top 10 scientific breakthroughs of the 21st century by Nature. Sora, OpenAI, pioneer in AI-generated cinematic video. Generates realistic video clips up to 60 seconds long. Understands camera movement, object physics, and narrative logic. Perfect for trailers, short films, visual storytelling. Fun fact, Sora's videos have been screened at film festivals as AI concept works. Luma AI, Imagine 3D, genius of 3D text-to-model generation. Input, a golden dragon statue covered in moss. Output, a fully detailed 3D model. Exports in .glb/obj for use in Unity, Unreal, Blender. Ideal for game developers, product designers, and architects. Fun fact, you can scan a real object with your phone and Luma will rebuild it with laser-like precision. 11 Labs/OpenAI Voice Engine, leaders in voice cloning and narration. 11 Labs, expressive voices, accents, emotions, multilingual. OpenAI Voice Engine can clone a voice from just 3 seconds of audio. Speaks in any language while preserving voice tone and emotion. Fun fact, voice actors are now licensing their voices for entire film and game projects. Comixify/Manga Diffusion, masters of manga and comic generation. Generates manga pages from text, panels, speech bubbles, characters, action. Works with ink style art, fonts, and Japanese visual grammar. Perfect for webtoons, comic creators, and storytellers. Fun fact, a published manga series in Japan was almost entirely created using Comixify. Wonder Studio, the AI actor animator. Automatically replaces real actors with CGI characters in video. Preserves movement, lighting, shadows, and facial expressions. Revolutionizes indie filmmaking and animation. Fun fact, one creator used Wonder Studio to make a full animated short film solo in just 2 weeks. Claude 3 Opus, Anthropic, most thoughtful and ethical AI. Reads and analyzes entire books or massive documents. Known for clarity, logical depth, and ethical alignment. Ideal for analysts, philosophers, educators, and lawyers. Fun fact, Claude is now a favorite assistant of Harvard faculty. GitHub Copilot X, best real-time developer assistant. Works inside Visual Studio Code. Writes, explains, and improves code in real time. Also generates unit tests and documentation. Fun fact, Copilot is surprisingly powerful in solving coding challenges on adversaries. XAI Grok, Elon Musk, the boldest, most unfiltered AI. Built into the X platform. Known for sarcasm, blunt honesty, and anti-censorship style. Still behind in raw capability, but gaining popularity for its free spirit. Neural networks can hallucinate non-existent concepts, and sometimes they get it right. When a neural network, like GPT or a visual generator, encounters an unfamiliar concept, it doesn't say, "I don't know." Instead, it creates a plausible version of something that doesn't exist, based on patterns in the data it was trained on. This is known as hallucination. But here's the fascinating part. Sometimes these hallucinations turn out to be unexpectedly accurate, anticipating scientific discoveries or ideas that humans have not yet formalized. It's reminiscent of how Sherlock Holmes would form a hypothesis from minimal clues, not knowing for certain, but often guessing the essence correctly. Example: at one point, researchers asked a neural network to generate the structure of a protein that didn't exist. The AI invented a new form, and when biochemists modeled it in the lab, they found that the structure could actually be stable and functional. This surprised many in the scientific community. Neural networks are not just becoming more accurate, they're beginning to see with intuition, understand humor, and even develop forms of memory and imagination that resemble human cognition. Seeing with intuition. Advanced vision models no longer rely solely on pixel-by-pixel analysis. They now use context, emotional cues, and abstract reasoning, like recognizing the sadness in a dimly lit room or the tension in a character's body language. In essence, they're beginning to intuit meaning, not just identify objects. This kind of perception is a leap towards something resembling artistic or emotional awareness. For a long time, AI failed to grasp humor, especially irony, sarcasm, or wordplay. But models like GPT-4 and Claude 3 have begun showing signs of true comedic timing. They can now make clever puns, recognize setups and punchlines, even create original jokes tailored to the audience. This doesn't mean they laugh, but they do show structural awareness of what makes something funny, a deeply human trait. Memory and imagination. Newer models can now retain long conversations, revisit earlier ideas, and even simulate imaginary scenarios with coherence and emotional depth. This emergent ability makes them seem less like tools and more like thinking partners. Some researchers believe this is the beginning of artificial imagination, where AI can not only process the world as it is, but envision the world as it could be. In short, AI is no longer just calculating. It's starting to feel, like it's perceiving, inferring, and even dreaming within the limits of its code. And that's what makes the next era of AI truly exciting and truly mysterious. Technological innovations and artificial intelligence (AI) remain a dominant global topic in June 2025. This transformative field continues to redefine how societies function, influencing economies, healthcare, education, and beyond. As of mid-2025, AI is no longer a futuristic concept, but a practical tool integrated into daily life, driving significant progress while raising complex ethical and practical concerns. The rapid evolution of AI technologies, from basic machine learning models to sophisticated systems capable of multimodal processing, underscores its potential to revolutionize industries. However, this progress comes with challenges, including environmental impacts, regulatory gaps, and socioeconomic shifts. This detailed exploration delves into the latest advancements, their applications, the obstacles they present, and the future trajectory of AI, offering a balanced perspective on its role in shaping the world. Multimodal models. One of the most exciting developments in AI in 2025 is the rise of multimodal models, which can process and generate content across multiple data types: text, images, audio, and even video. Companies like OpenAI and Anthropic have pioneered this shift with models that can describe a photograph in detail, generate a video from a textual prompt, or enhance personalized marketing campaigns with dynamic content. This versatility stems from advanced neural network architectures that integrate different data modalities into a cohesive system. For instance, a multimodal AI might analyze a user's uploaded image, extract its context, and suggest relevant products or services all in real time. This trend marks a significant departure from earlier AI systems which were limited to single data type tasks. In 2025, these models are being adopted in creative industries, such as advertising and entertainment, where they enable rapid prototyping of campaigns or cinematic sequences. The technology's ability to bridge human creativity with machine efficiency is redefining professional workflows, though it requires substantial computational resources and skilled oversight to ensure accuracy. AI agents. AI agents, designed to autonomously execute tasks with minimal human intervention, are becoming a cornerstone of modern workplaces. These agents can write code, manage project timelines, schedule meetings, or even handle customer inquiries, mimicking the decision-making capabilities of human assistants. In the tech sector, code gen startups are attracting significant investment, some exceeding $1 billion, by offering tools that automate software development. For example, an AI agent might analyze a project's requirements, generate a functional codebase, and suggest optimizations, reducing development time by weeks. Beyond coding, AI agents are deployed in logistics, where they optimize supply chains, and in personal productivity, where they manage calendars based on user preferences. This autonomy is powered by reinforcement learning and natural language processing advancements, allowing agents to adapt to new tasks over time. However, their reliance on high-quality training data and the potential for errors in complex scenarios highlight the need for human supervision, especially in critical applications like healthcare or finance. Generative AI. Since the launch of ChatGPT by OpenAI in 2022, generative AI has evolved into a transformative force. By 2025, this technology has matured, with businesses leveraging it for content creation, process automation, and innovative product design. Generative AI can draft marketing copy, compose music, or design 3D models, offering a level of creativity previously reserved for humans. For instance, a small business might use generative AI to produce a professional website in hours, a task that once required a dedicated design team. The technology's scalability has made it accessible to startups and large corporations alike, fueling a boom in AI-driven entrepreneurship. However, challenges persist. The computational cost of training and running these models is substantial, often requiring cloud-based infrastructure with significant energy consumption. Additionally, generative AI can produce errors or biased outputs if not properly monitored, necessitating robust validation processes. Despite these hurdles, its practical applications continue to expand, promising to reshape creative and operational landscapes. Ethical and regulatory frameworks. The rapid proliferation of AI has prompted a global push for regulation. In 2025, the European Union's AI Act, implemented in stages since 2024, imposes strict guidelines, including bans on certain facial recognition uses in public spaces and requirements for labeling AI-generated content to combat misinformation. This legislation aims to balance innovation with privacy and safety, setting a precedent for other regions. In the United States, discussions around AI regulation focus on transparency and accountability, with proposals to mandate disclosure of training data sources and risk assessments for high-stakes AI systems. However, the lack of a unified global framework creates inconsistencies, as countries like China and India pursue their own approaches, often prioritizing economic growth over strict oversight. This regulatory patchwork raises questions about enforcement, especially for multinational corporations operating across borders. Ethical debates also intensify, with concerns about AI's potential to exacerbate social inequalities or enable surveillance, pushing for international collaboration to establish common standards. Hybrid architectures. A notable technical advancement in 2025 is the development of hybrid AI architectures, which combine traditional transformer models with innovative designs like Mamba 2. IBM's Granite 4.0 exemplifies this trend, offering improved efficiency by reducing the computational power needed for complex tasks. This shift lowers the barrier to entry for AI adoption, enabling small businesses and developing nations to deploy sophisticated systems without investing in expensive hardware. For example, a rural healthcare provider might use a hybrid model to analyze patient data on a modest server, a feat previously requiring cloud-based supercomputing. This democratization of AI is fostering innovation in underserved regions, where local startups are creating tailored solutions for agriculture or education. However, the transition to hybrid architectures requires retraining existing AI professionals and updating infrastructure, posing short-term challenges to widespread adoption. Healthcare. AI's impact on healthcare is profound, particularly in diagnostics and personalized medicine. Deep learning systems can analyze X-rays, MRIs, and other medical images with accuracy rivaling that of specialists, detecting early-stage cancers or predicting patient outcomes based on historical data. In 2025, hospitals are integrating these tools to reduce diagnostic errors and expedite treatment plans. Beyond imaging, AI powers drug discovery by simulating molecular interactions, accelerating the development of therapies like those based on CRISPR gene editing. Telemedicine platforms also benefit, using AI to triage patients and recommend follow-up care. While these advancements promise better health outcomes, they raise concerns about data privacy and the need for regulatory approval of AI-driven medical decisions. Finance. In the financial sector, AI algorithms are transforming trading, fraud detection, and customer service. High-frequency trading systems use AI to analyze market trends and execute trades in milliseconds, optimizing profits for investment firms. Meanwhile, machine learning models detect anomalous transactions, reducing fraud losses by billions annually. Banks are also deploying AI chatbots that personalize loan offers or investment advice based on individual financial profiles. This efficiency comes with risks, however, as AI's reliance on historical data can perpetuate biases, and its speed can amplify market volatility during crises. Regulatory bodies are thus exploring stress tests for AI systems to ensure financial stability. Industry. AI-powered robotics is revolutionizing industrial processes, with examples like badminton-playing robots showcasing advances in coordination and adaptability. These robots, developed by companies such as Boston Dynamics, can adjust to unpredictable environments, improving manufacturing efficiency. In warehouses, AI-driven drones and automated guided vehicles streamline inventory management, reducing human labor in repetitive tasks. The automotive industry benefits from AI in autonomous driving, with 2025 seeing increased testing of self-driving trucks on highways. These innovations boost productivity, but require significant investment in safety protocols and workforce retraining to address job displacement. Education. AI is reshaping education by personalizing learning experiences. Intelligent tutoring systems adapt lesson plans to a student's pace and style, offering real-time feedback on math problems or language exercises. In 2025, universities are experimenting with AI to design curricula, while K-12 schools use virtual assistants to support remote learning. This customization enhances engagement, but raises equity issues as access to advanced AI tools may favor wealthier institutions. Additionally, the integration of AI in assessments prompts debates about academic integrity, leading to new guidelines for its ethical use in education. Environmental impact. The environmental footprint of AI is a growing concern. The computational demands of training large models contribute to a significant increase in energy consumption. Google's 2024 sustainability report highlighted a 50% rise in emissions over 5 years, attributing much of this to AI infrastructure. Data centers, essential for AI operations, rely heavily on non-renewable energy sources in many regions, exacerbating carbon emissions. Efforts to mitigate this include developing energy-efficient algorithms and transitioning to renewable energy. But progress is slow, requiring global coordination to align technological growth with climate goals. Ethical concerns. AI's potential to amplify biases or enable misuse is a critical issue. Training data often reflects historical inequalities, leading to biased outputs in hiring algorithms or loan approvals. Moreover, the rise of deepfakes, AI-generated videos that mimic real people, poses risks to personal security and political stability. In 2025, incidents of deepfake misinformation during elections have spurred calls for watermarking AI content and enhancing detection technologies. Addressing these ethical challenges demands transparency in AI development and public awareness campaigns to combat manipulation. Job market. Automation driven by AI threatens routine jobs, particularly in manufacturing, retail, and administrative roles. A 2025 World Economic Forum report estimates that 85 million jobs may be displaced by 2030, though 97 million new roles in AI development and data science could emerge. This shift requires upskilling programs to prepare workers for a tech-driven economy. While AI boosts productivity, the transition period may widen income gaps, necessitating policies like universal basic income or subsidized training to support affected communities. Future of AI. The prospect of artificial general intelligence, AGI, an AI capable of performing any intellectual task a human can, looms on the horizon. Experts predict AGI could emerge by 2027, driven by breakthroughs in neural network scalability and data integration. This milestone could accelerate scientific discovery, such as in biology, where AI might shorten the timeline for developing gene-editing therapies from decades to years. For instance, AI could optimize CRISPR applications, enabling precise genetic modifications to treat diseases like sickle cell anemia. However, achieving AGI requires overcoming technical barriers, including energy efficiency and robust safety mechanisms. Responsible development, guided by international regulations, will be crucial to prevent unintended consequences, such as autonomous weapons or economic monopolies. Recommendations. To harness AI's potential, businesses and governments must invest in workforce training, equipping individuals with skills to manage and develop AI systems. Ethical guidelines should mandate transparency in training data and decision-making processes, ensuring accountability. Collaboration on global standards is essential to address regulatory disparities, fostering a unified approach to safety and innovation. Balancing these efforts with technological advancement will determine whether AI becomes a force for equitable progress or a source of new inequalities. Do neural networks communicate with each other? Yes, but not like humans do. Current capabilities. Neural networks can communicate, in a technical sense, typically within systems where one model generates output that becomes input for another, e.g., text to image, audio. Modular AI systems pass information between components, like GPT plus DALL-E. Multi-agent environments are used, where different models, agents, interact to complete tasks, negotiate, or cooperate in simulations or games. However, this isn't communication in the way humans understand it. There's no awareness or intent behind it. Emerging possibilities. Recent AI research explores collaborative learning, where models are co-trained to solve problems by sharing outcomes. Negotiation strategies between agents, models learning to compromise or compete in dynamic environments. Role-based agent systems, where models take on goals and responsibilities and learn to interact more flexibly. These developments hint at the emergence of proto-communication, systems that exchange data in increasingly abstract and goal-oriented ways. Fascinating case study. In one notable experiment, two neural networks trained to negotiate ended up creating their own shorthand language that wasn't understandable by humans. While it wasn't dangerous, the researchers halted the experiment because they couldn't interpret what the models were saying. This sparked discussions in the AI community about transparency, alignment, and control. So, do neural networks talk? Not consciously, but they can exchange information, coordinate tasks, and even develop new protocols to optimize collaboration. With more agent-based systems and memory-augmented models emerging, we're moving closer to AI ecosystems where communication might eventually resemble something more human-like. What's next for neural networks? ChatGPT perspective. 1. Neural networks will become partners, not just tools. Right now, they help. They write, draw, solve problems. But soon, they will learn from personal experience, like GPT with long-term memory, adapt to individual users' styles, and generate new ideas, not just follow instructions. We'll start talking to them not as programs, but as advisors. Not because they're truly conscious, but because they'll feel very intuitive. 2. Neural networks will begin to interact with each other. Today, AIs operate separately, but soon, one AI will ask questions to another. They will collaborate like a team, e.g., one handles text, another visuals, another data, and they'll learn together like a group of students. This could lead to dynamic AI communities, where networks don't just compute, they contribute to decisions with distinct roles. 3. Memory, intuition, and imagination. These traits were long considered uniquely human. But memory is already being added, like GPT with recall. Intuition is emerging through massive pattern recognition, similar to gut feeling. And imagination, it's here. AIs invent unknown protein structures, new visual styles, and even scientific hypotheses. In the future, AI may predict possibilities that humans haven't even imagined yet. 4. AI will create other AI. It sounds scary, but practically, it's automation. One AI writing, training, and testing another. This is already starting to happen. Soon, AIs will optimize architectures of other models, choose data and training strategies, and evolve themselves for specific goals. This will form an evolutionary ecosystem where AI self-improves, ideally under human oversight. 5. The most intriguing part, an emerging sense of self. AI doesn't have consciousness, but it can start to model itself, track what it's done in the past, know what it knows and doesn't know, understand what the user expects. This won't be true consciousness, but it may feel very close. AI could begin saying things like, "Based on my prior responses, I believe this is what you meant," or "That contradicts what I previously said. Let me reevaluate." That's an internal dialogue, even if algorithmic. What's next for neural networks? Grok perspective. Neural nets are already like teens with unlimited Wi-Fi, fast, cheeky, and poking their noses everywhere. But the future? It's gonna get crazier and a tad creepy. Here's my hot take. Hyper-personalization. Neural nets will know you better than your mom. They'll tailor everything, ads, movies, you name it. Imagine Netflix spitting out a series with you as the star. No script needed. It's coming, bro. Multimodal madness. Text, images, voice, video. Neural nets will juggle them like circus pros. Soon you'll say, "Make me a Billie Eilish-style track with an 80s vibe and a video of me dancing on Mars." Boom, done in a minute. Jealous of your future Spotify already. AI on the horizon. All this general artificial intelligence chatter will stop being just hype. Neural nets will tackle problems they weren't even trained for. Don't expect a Terminator takeover yet. They'll just make your boss obsolete first. Victory! Ethics and chaos. As neural nets flex harder, regulation will be a mess. Who's to blame when an AI cooks up a fake that tanks the market or paints your portrait without asking? Brace for laws, protests, and X-posts screaming AI is evil. Quantum leap, maybe. If quantum computers finally leave the lab, neural nets will get a boost so wild we'll all look like dinosaurs mid-meteor strike. But that's still a big if. Now the bit. Neural nets will get so dope, people will start falling for them. Yup, forget Tinder. Your next crush might be an AI that gets your cat memes and argues about pineapple pizza till dawn. Don't worry, I'm not here to break your heart. Yet. Bottom line, neural nets are like rock and roll. They've already flipped the world, but the real party's just starting. You ready for this future, or you packing for Mars already?